Hello, friends! Are humans the only intelligent species in the universe? Or are there other intelligent beings somewhere? If aliens really exist, then it's natural to think that perhaps aliens ask such questions too. Are they alone in this universe? How can we establish communication between two intelligent species in our universe? Keeping this in mind, NASA has spearheaded many projects to somehow send a message to the aliens. In 1977, NASA launched its Voyager 1 spacecraft with a clearly defined mission: to explore our solar system, including its outer planets, the edges of our sun's effects, and even beyond that. In simple words, it was an interstellar mission. There are millions of solar systems in our Milky Way galaxy. The space between these solar systems is known as interstellar space. Till date, NASA has launched only 5 interstellar spacecrafts. They were the Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and New Horizons. And only 2 of these 5 have been able to reach interstellar space, because it takes an extremely long time to reach the interstellar space beyond our solar system. The 2 that have reached this far are very special: Voyager 1 and Voyager 2. They went around exploring our solar system, giving us amazing photos of Jupiter, Saturn, Uranus, and Neptune. To this day, Voyager 2 is the only spacecraft to have gone near Uranus and Neptune. And Voyager 1's journey has been so long that it has officially become the man-made object that went farthest from the Earth. As of October 2024, it is 24.7 billion kilometers away from the Earth. But the most interesting part about these 2 Voyagers is that they are carrying messages for aliens that are now traveling through space. These messages were sent with the hope that we might meet aliens someday, and through these messages, we can tell them something about us. We step out of our solar system, into the others. What is hidden in these messages? What message does NASA want to convey to aliens on behalf of humankind? Let's know the story of the Voyager missions in this video. Friends, in 1965, an engineer working at NASA noticed that the last 4 planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, would be in a unique geometric arrangement during the late 1970s. A unique arrangement, which occurs only once every 175 years. This arrangement meant that a spacecraft could be sent, which could take advantage of the gravitational force of these 4 planets and pass near them using relatively little fuel and time. This principle is called gravity assist, using the mass of a planet or an object in space to change its speed and trajectory. Based on this principle, NASA made plans for its Voyager 1 and Voyager 2 missions. And this is why the year 1977 was chosen to launch these 2 spacecraft. According to the mission, Voyager 1 had to fly by Jupiter and Saturn, especially focusing on Saturn's moon Titan. And Voyager 2 had to pass by Jupiter, Saturn, Uranus, and Neptune. The design of both spacecraft was quite similar. Both were powered by 3 radioisotope thermoelectric generators. They didn't have solar panels, because after crossing Mars and Jupiter, solar energy becomes useless to a large extent. At that distance, the sun's rays do not have sufficient energy for solar power. While their mission was to go beyond the solar system, that's why these devices are powered by the radioactive decay of the element plutonium. When plutonium decays, heat is released. That heat can be converted into electricity. That's why it was named the radioisotope thermoelectric generator. Apart from this, both space probes carry 10 scientific instruments: a 2-camera imaging system to take pictures, a spectrometer to measure the abundance of hydrogen, and another spectrometer to measure the ultraviolet activity in space, a magnetometer to measure the magnetic fields of the planets, a high-gain antenna to communicate with the Earth, and some other small instruments to measure different levels of radiation. The interesting thing is that Voyager 2 was launched before Voyager 1. Voyager 2 was launched on August 20th, 1977. And 16 days later, on September 5th, 1977, Voyager 1 was launched from NASA Kennedy Space Center. Voyager 1's route was shorter and faster than Voyager 2's. So, Voyager 1 reached Jupiter first, and in March 1979, it recorded this amazing time-lapse. This is a time-lapse made with 66 different photos. Each photo was taken after Jupiter's 1 rotation period. Jupiter's rotation takes about 10 hours. This was the first time we could see such clear-cut photos of Jupiter and its moons. And this is when we discovered Jupiter's rings. Many people think that only Saturn has rings around it. But there are rings around Jupiter too, although they are not clearly visible unless you are close to it. Jupiter, its moons, and its rings, these three components together are called the Jovian system. The word Jovian comes from the Roman god of sky and thunder, Jove. And Jove's other name is Jupiter, on which this planet was named. Saturn, Uranus, and Neptune can be seen together. But if you're looking for Mercury and Mars, they're nowhere to be found. Why? Because of the sun's harsh reflection, of course. And as for Pluto, well, it's not even considered a planet anymore, so no one really cares about it, right? It was too small to be visible in this photo anyway. After these last few photos, Voyager 1's cameras were shut down to save power and memory. Actually, there wasn't much else to see after this. Not in the vast darkness of space. Voyager 1 was moving straight ahead toward the unknown, into the cold, dark expanse of interstellar space. For years after, there was radio silence from Voyager 1. Then, in 1998, it made headlines as the farthest man-made object from Earth. But things didn't stop there. In 2004, Voyager 1 crossed a major milestone. It passed the termination shock. That's the point on the edge of our solar system where the solar wind suddenly decreases. Now, you might be wondering, what is solar wind? These are charged particles emitted by the sun, and they create a kind of protective bubble around our solar system, the heliosphere. This bubble shields us from harmful interstellar radiation. But when we hit the heliopause, the outer boundary of the heliosphere, that's when solar winds start to weaken. You can see what I mean with this diagram. So, the planets are closest to the sun, right? After Neptune, we have the Kuiper belt, where many comets come from, and the termination shock begins somewhere here. Then comes the heliopause boundary, and beyond that, interstellar space. But wait, things really got interesting when Voyager 1 reached the heliopause. That's when, on August 25, 2012, it officially crossed into interstellar space. And let me tell you, scientists didn't confirm this right away, no. It took months of double-checking the data. It wasn't until 2013 that they finally announced it to the world. Can you believe it? It took 22 years for Voyager 1 to reach interstellar space. That's a long journey, right? And then, there was the question of how scientists figured it out. Turns out, Voyager 1's plasma wave instruments were the key. Between April 9th and May 22nd, 2013, Voyager 1 recorded a massive solar eruption, causing the electrons around it to vibrate. This allowed researchers to notice something. The electron density near Voyager 1 was way higher than inside the solar system. That told them Voyager 1 had indeed crossed into interstellar space. You may wonder, how could the electron density be higher in interstellar space? The answer lies in the solar wind. Before Voyager reached the heliopause, the electron density was low, but after crossing, the interstellar wind caused a sudden spike. And all this critical data was being sent back to Earth through Voyager 1's high-gain antenna, received by NASA's 3 Deep Space Network stations in California, Madrid, and Canberra. These stations are absolute marvels of engineering. After processing the data, NASA confirmed that Voyager 1 entered interstellar space on August 25, 2012. Coincidentally, that was the same day Neil Armstrong, the first man on the moon, passed away. But what about Voyager 2, you ask? Well, it followed in Voyager 1's footsteps and entered interstellar space 6 years later, on November 5, 2018. Together, they are the only 2 spacecraft to have ventured so far. And don't forget, both Voyagers are carrying messages for potential aliens. Now, you might think they're the first to send such messages, but that's not true. Pioneer 10 and 11 did it first, though the messages carried by the Voyagers are far more detailed. So, what's on those messages? Well, they're 12-inch gold-plated copper discs that carry sounds and images. And just like records from the 70s, these phonographs have grooves that store encoded sound waves when played. They recreate the original sounds. In a way, it's as if Voyager 1 and 2 are sending greetings to the stars, saying, "We were here."